expression right here, x squared plus 8x plus, let's say, 2. And I said factor that. What would the challenge be if you tried to search for a way to factor that one?
Well, there's only one way to get.
There's only one way. It's a leading coefficient is 1. There's only one way to get 2. But the challenge is there any outcome that works for you?
No, right?
Not really. So in this case, up until this point, you would say that that's prime, right? Now, that doesn't necessarily mean there aren't any solutions if we made it equal to, say, 0. You know, if we made it equal to 0, theoretically, might we be able to find some sort of, yeah, we could. When we factor, we've only factored with integers. You could factor with some fractions, but maybe it's imaginary. No, not in this case. Now, it's an expression, so there isn't two sides to this. Golden rule of algebra says what we do to one side, we have to do to the other side. Okay, so here's a maneuver that doesn't change the overall value of the expression. If we had an equal sign, if we added 5 to one side, we'd have to add 5 to the other side. If we divided by 5, we'd have to divide by 5, right? We could multiply everything by 1, right? Some crazy form of 1. Remember when we rationalized denominators, we multiplied by like √2 over √2? That doesn't change the overall value. Another thing, and this is the new thing, if you add and subtract the same thing, do you change the overall value? If I added r and I subtracted r, does that change the overall value of the equation? No, it doesn't. If I add and subtract the same thing, it does not change the overall value of the expression. So let's say, for example, I'm back to looking at this original one. Let's just say, for example, I added and subtracted the same thing. And I want to move this 2 over right here. So let's say I'm going to add and subtract. I'm going to add and subtract 16. Have I changed the overall value of the expression? No, I haven't. Absolutely haven't. Let's look at a part of this now. Let's just look at this part right here. Can you factor this for me? Can anybody factor that for me? Raise your hand. Can you factor that for me? It factors nicely. I'm telling you now. Can someone raise their hand? I'll call on you and just tell me what it is. Nick, what is it?
X plus 4.
Yeah, it's x plus 4 squared, right? What's left on the outside here? Minus 16 and plus what? 2. So if you wanted to simplify this a little bit, you'd end up with x plus 4 squared minus what?
16 plus 2. Or
14. Thank you. So what have we shown? We've shown that this equals, that equals x plus 4 squared minus 14. The magical step was right here. We added and subtracted the same thing. There's that magical step. I haven't told you what the value of this maneuver is yet, but we need to break this down into small pieces first before you get to the overall value. Okay? So what our goal is to figure out where that 16 came from. So Nick, give me an even number, any even number you want. Let's say we had 6x, and give me any number, Connor, between 1 and 10.
3.
So let's say I gave you that right there. And I said we want to do what we just did, which is called completing the square. That's what we're learning how to do today. If I ask you to complete the square, you're not changing the overall value, and you need to add and subtract the same thing. Anybody want to guess, based on what we did up here, what we should add and subtract this time? Anybody want to guess?
12.
9.
12 and 12.
So we could try 12, but let's try 9. Does it change the overall value if I go plus 9 minus 9? No, it doesn't. So let's look at the first 3 right here. Does that factor, Mar? What does that factor into?
X plus 3 squared.
This is x plus 3 squared, and then we have minus 9 and minus 3. It's minus what? 12. So we've turned this into, we now know that this is the same thing as x plus 3 squared minus what? 12. So let's try another one and see if you can figure out where Mar got that 9 from. Zoya, give me a number between 1 and 10.
7.
Plus 7x, an even number.
So it's an equal.
Yeah, an even number.
4.
4. And Emmett, give me an odd number between 1 and 10. Oh, Emmett's not here. Alex.
Number between 1 and 10?
Yeah.
9.
9. So that right there, does that look nicely factorable? It really isn't. We're going to factor this by, we're going to end up factoring this by completing the square. So what's that first thing we're going to do? We're going to move these over. And then you have minus 9. Anybody want to guess? Anybody new want to guess what the numbers we're going to add and subtract? We're going to add and subtract the same thing and put them right here. Say it. Just it's okay. What is it?
4.
Plus 4 and minus 4. Let's try it and see what happens. Let me change the color. I wanted to be more consistent with my color today. So we have plus 4 and minus 4. So what do? We look at this right here. Does that factor nicely? Yeah, what does that factor into? That's x plus 2 squared, and now we have minus what? 13. So we now show that this is x plus 2 squared minus 13. Anybody want to guess? So what was the magic number that we've come up with each time? We came up with 4 here. What do we come up with here? 9, right? 9 is right there. And then we came up with 16 right here in the first one. Can anybody see what the pattern is? How did we? So it was 16, 9, and 4. And yeah, what is it, Harry?
Isn't it the square of whatever half the middle number is?
Well, the middle number here, let's look at this one. The middle number here is 8, right?
Yes, it's the square root of 4. I'm not square root, the square of 4.
The square of 4? So it's 4. Hold on. So yeah, 4 squared is 16. Half of 6 is 3. 3 squared is 9. Look at that. It's half of it squared. Half of it squared. Let's see if it works. Give me an odd number, Harry.
9.
And let's say I'm just going to pick one here. Minus, let's say minus 13. Now those aren't very nice numbers, right? So what number do you? Let's stay in even land for now. I'm sorry. Let's stay in even land. Let's go with 10x minus 13. It's still not nice. So what's our middle number here? 10. What's half of 10? 5 squared is? So we have x squared plus 10x plus 25 minus 25 minus 13. And now we're just looking at the front here. What is that going to factor into? Yep, and minus what? Yeah, 38. So you're taking half of the coefficient and squaring it. Half of it and squaring it. Let's see if this always holds true. Now, I've been choosing even numbers specifically because if I chose, let's say 9, Harry wanted to do 9 right here. So it was minus 12, like this, something not so good. What's our middle value here? What's that middle coefficient? 9. What's half of 9? I really don't like decimals, remember. 9 over 2. So what do we think we're going to add and subtract? Remember, it was half of it squared, right? So it's going to be, what are we adding and subtracting?
1 over 4.
Okay, 9 over 2 squared. Just leave it like that for now. Have we changed the overall value? Have we changed anything? Everybody stand up.
No, we haven't.
Stand up. Everybody stand up. Have we changed anything?
No.
Why?
Because we're adding and subtracting the same value.
Yeah, we've added and subtracted the same value. Correct. So this is what's the only difference now? Now it's a fraction. Ooh, we're terrified, right? All of a sudden we're terrified. It's the same process. So can you tell me, Mar, or anybody, can you tell me what this factors into? It's going to be x plus what? Something squared.
Half of 9.
Yes, it's just x plus half of 9 squared. It's x plus 9 over 2 squared minus 9 over 2 squared minus 12. The only thing that's different is it's slightly a little bit more friction to combine these things. But have we done the same exact process? Yes, we've done the same exact process.
Have to do that. Just simplify that.
Yeah, we'd have to simplify. Can you handle simplifying that? Sure. We've just redone this. Okay,
To find
in 1. Does that make your life easier? So the rule we just came up with, half of that squared, only works when it's 1 in front. You have to remember that. That's really important. So the first level of difficulty is going to be 1 in the front. Is that the same level of difficulty we worked with before? Absolutely. Okay, sit down. On this one right here, it's going to be x squared plus 5x plus 5 over 2 squared minus what? Minus 2. So what does this factor into right there? X plus 5 over 2 squared, and then you have to simplify this fraction right there. This has to be simplified right to there. And then there's another one on the side. I want to give you a couple more minutes to try to tackle those. Just take a look. Question for you. What's different about number 4? What's the only thing that's different? Leading coefficient is not 1. Now here's the thing. At that point, you probably feel like you need to do what? Cry? Did I hear cry? Divide, right? The challenge is if you divide by 2, have you changed the overall value of the equation?
yes.
Yeah, so you can do something that's almost the same. You can't divide by 2. What could you factor out? You can factor it out and make it 2 times x squared plus minus 3 over 2. Have you changed the overall value? No. So now what do? You just do what you needed to do right there. You factored out the 2, so now you just complete the square on the inside. In this case, there's just two fractions. So you might be asking yourself, what's the point of this? Maybe. How many people have wondered that? What's the point? Okay, here's the point. Stand up. Stand up. That's not the actual point, but it'll help you understand the point. Here's the point, everybody. So let's go back to one we looked at before. So let's say we started, what did we start with? X squared plus 8x plus 2, right? Let's say I gave you this right here. X squared plus 8x plus 2 is equal to 0. And I said solve that equation. This is now an equation because what does it have in it? It has an equal sign. If I ask you to solve that equation, up until this class, you try to factor, right? The challenge here is that nicely factorable? No, that's so not nicely factorable. We've been calling it prime. It's not technically prime because you can factor it, but for our methods, you can't really factor it. But what could we do to that thing on the left? What could we do?
Subtract 2.
What was this method called that we were just doing? Completing the square. So if we space this out a little bit, and we have the plus 2 right there, it equals 0. What can we add and subtract right here? 16. So let's add 16 and subtract 16. Have we changed the overall value? No. What does this now factor into? We just did this one. What is in the purple there? What does that factor into? X plus 4 squared, and then minus 16 plus 2. What does that simplify to? Minus 14 equals what? 0. What can I add to both sides? X plus 4 equals 14. Oh, what can you do to both sides? No, it is squared, so what can you do? Cube root? Where are the cubes coming from? Yeah, this is why the test went really weirdly. That's a square, so how do you get rid of a square? Square root it. So what did I tell you before? When you take the square root, what's the answer going to be? The square root of 14 and what else? Yeah, it's plus or minus. This is really important. Everybody see the plus or minus there? If I have x squared equals 9, what's one possible answer? 3. What's also an answer? Negative 3. So when you actually take a square root, when you add in the square root sign, you have to add in plus or minus. What does this mean at this point? This is super important. It means that x plus 4 equals root 14, or what? X plus 4 is equal to? Negative root 14. So there's two answers. So x is equal to negative 4 plus root 14, or x is equal to negative 4 minus root 14. There are two possible answers to this.
Write that as negative 4.
You're done. There's nothing to do with that. You can't do anything. There's nothing to do because can you break down square root of 14?
I'm saying you can write the answer to the.
Oh yeah, I'm sorry. Yeah, you could write x is equal to negative 4 plus or minus root 14. Yes, absolutely. But you just need to. The important thing is you need to be very careful. It is two cases at this point. It's two cases.
Where do we get the plus or minus?
Because if I gave you x squared equals 9, Nick, what's one possible answer? 3 or what? Negative 3, because negative 3 times negative 3 is what? 9. 3 times 3 is 9. What I'm trying to get at is to go from this step to this step, you had to take a square root. Whenever you take a square root, it's going to generate a positive and a negative answer. That is super important in this case. What this allows for is, did we have a way of solving this up until today? No, we didn't. Completing the square is a great way to solve any quadratic. Any quadratic. So let's try another one. Sit back down. Solve this one for me. Solve that one for me. Factored before? Was this one we factored before? It actually was. Yeah, what do you have to add and subtract? 25. You have this, right? Nice. What does this factor into right there? Yeah, x plus 5 squared minus 38 is equal to 0. So x plus 5 is equal to 38. So x plus 5 is equal to plus or minus the square root of 38. So x is equal to negative 5 plus or minus the square root of. This is really cool, everybody. I don't know if you do fully understand the power of what you've just been able to do. You can make up essentially any quadratic you want and solve it without factoring. Does it get a little tiny bit more annoying if you have some nasty fractions? Sure, but does the method change? No. So the last bit of this is the following. What's the leading coefficient right here? 1. 1 is the leading coefficient. Does the leading coefficient always have to be 1? No. So let's say, for example, it wasn't 1. Let's make one up. Let's just make one up totally. Let's say it was 2x squared plus 16x minus 28 is equal to 0. What do you think you should do first? You could factor out 2, but now that it's an equality, can we divide by 2 on both sides?
Yeah.
Absolutely. Now that it's an equality, you are allowed to divide by the same thing. And what's cool here? What's it equal over here?
0.
What's 0 divided by anything?
0.
So what can you always do first?
Divide by.
Yeah. Do you remember what the general form of a quadratic is? Do you remember how you say it generally? It was ax squared plus what? bx plus c. How many people have seen that before? We've written it down a couple times. This is the really common way to write a quadratic down. The leading coefficient of x is usually called a. So what do you think your first step should always be when you're completing the square? Divide by a. Because if you divide by a, what's the leading coefficient always going to become? What's a over a? 1. So step 1 is always going to be divide by a. So in this case, what is a equal to? A is 2. Does everybody see how a is 2 right there? So if I divide by 2, what do I end up with, Connor? If I divide the entire equation by 2, what do I end up with?
X squared.
Yep.
Plus 8x.
Yep.
Minus 14.
Equals?
0.
0. So what was our next step? We have to add and subtract what? Add and subtract what? Yeah, subtract. It's going to be half, and we'll call it half squared. I'm going to be more specific later, but half squared. Half of what squared?
8.
8. Right here? You see that? So what are we adding and subtracting then? What's that going to be? 16. So what does it become? X squared plus 8x plus 16 minus 16 minus. And then what's our third step here? Yeah, we're going to factor for our third step. And what is that going to factor into? X plus 4 squared. Factor and simplify, I guess I'll say. Minus 30. And what does that equal?
0.
Equals 0. And then, really, your lesson is just going to be solve. So if you solve this, it's going to be x plus 4 squared is equal to 30. So x plus 4 is equal to plus or minus what? Yep. So x is equal to negative 4 plus or minus the square root of 30. Now at this point, we've just solved the quadratic. Have you solved many quadratics before? Absolutely. What's that last step you like to check? Here's the thing. If I said to you, please check this, what would you think to yourself? Nah, right? Do you really want? Now, you know how to multiply radicals, right? Theoretically, could you take this and plug it in up here? Theoretically. Would you want to?
No.
Not really. Generally speaking, I'm not going to require you to check nasty answers like this unless I specifically tell you to. You understand? So if I give you a completing the square question, unless it's really easy to check the answer, don't worry about it. Because could it be really kind of annoying to plug this in and simplify?
Wait, would you put?
You would plug 4 plus root 30 in for x.
Oh.
So you have to square it and multiply it by 16, subtract 28, and hope it comes out to 0.
I thought it was either negative 4 or square.
No, it's either you plug in 4 plus root 30, sorry, negative 4 plus root 30, and then the second time you do negative 4 minus root 30. There's 2 answers to check. Do you really want to do that? Probably not. Nick, go ahead. Crudely drawn. So we're solving, we spend a lot of time looking for zeros. You see those zeros right there? So for example, that function could be y equals some function f of x. If I were to divide both sides of the equation by, if I was to divide the right side by 2, the zeros don't change, because what is 0 divided by 2? One way to remember it. What's 0 divided by anything? So if you plug something into an equation that makes it 0, does it matter if you divide by a billion? No, it doesn't change the zeros. Does it change the shape of the graph? Yes, if you start multiplying by a constant, so let's say that y is equal to some constant times the function. So multiplying by half is the same thing as dividing by 2, right? If you start multiplying by a constant, what happens? It starts changing the shape. The graph starts looking like this. It might flatten out like this. it might go steeper like this. But what doesn't change?
The points.
The zeros don't change. So when you divide by 2, Nick, when you divide by 2, it changes the shape of the graph, but does it change the zeros? No. So when we're looking for the zeros, so do we care what the shape of the graph looks like? Not really. We want the zeros, right? So, but it's really important to realize, yes, have you changed the shape of the graph if you graph the function? Yes, but it doesn't change the zeros. So. Nice. Divide by 2. I like that. So you divide by 2 and you end up with x squared plus 7x minus 9 over 2 is equal to 0. Can someone tell me what the next thing I have to determine is? Half of 7 squared. And what am I going to do with that, Harry? With half of 7 squared?
You're going to square and add it.
That's literally what I do. What are we going to do with the value 7 over 2 squared?
Oh, you're going to
Add it and subtract it. So does that change the overall value of anything? No. So you have this still equals 0. So all we've done is we've added 7 over 2 squared and we've subtracted 7 over 2 squared. Oh, now what's the one word for what we're doing next? We take this and what does it factor into, Mar? X plus?
X plus 7 over 2.
Yeah, squared. I know that was hard for you to say. Minus 49 over 4 minus, I'm just doing the fractions out now. You have to do a bit of cleanup, right? To add or subtract fractions, what do you have to do? What do you have to have? What do you have to have to add or subtract fractions, kids? Common denominator. Yay, all right, yay. So it's 49 over 4 minus 18 over 4. So what's that going to be? Oh, yeah, something over 4. Correct. I like that. I like the specificity, Mark. Something over 4. Negative 67. So what do you end up with? X plus 7 over 2 squared minus 67 over 4 equals 0. And now you can just, you're home free, right?
Yeah, I can stop there.
It's 67, right? Because it's negative 49 minus 18 is going to be negative 67. What do you do to both sides? Square root. So what happens when you take a square root?
You have both negative and positive.
67 over 2. So what do we end up with here? X equals negative 7 over 2 plus or minus the square root of? When you end up with an answer like this, it definitively means there's no nice way to factor it. If you ever complete the square and you end up with a nice answer like 2 and 7, what does that mean about the original equation? It could have been factored nicely. Exactly. And that's going to happen. You're going to look at something and be like, you know what? I can't factor, so I'm just going to complete the square. This is nice because it works every single time, right? Yeah. Any quadratic, you can come up with an answer, even if it's imaginary. It'll give you an answer.
Whoa. Yeah.
Whoa. Wow. Whoa. Mind blown, right? But here's the thing. If you end up with a nice answer, it probably means you could have factored it, but hindsight is what? What do they call hindsight? 20/20, right? So what? You still have the answer, right? This is useful because it works every single time. Are you going to use it every single time? No. When you look at a quadratic, can you evaluate it decently quickly if it's factorable or not? Like decently quickly? Like x squared plus 6x plus 9. Oh, that's x plus 3 squared. Like you now have seen enough of it. But here's the thing. Multiplication is easy because it's just an algorithm, right? Factoring is hard because is there just one way to factor? No. You have to be creative about it. That being said, completing the square, while a little complicated, look at that answer. Is that a nice answer? No. Well, relatively could be worse, but compared to the answers we were getting before, is that a nice answer? That's ugly, but are you relatively confident it's correct? Yeah. Also, is this a rational or irrational answer? This is irrational because we are root 2 in the denominator, right down there. So yeah, factoring would not be nice on this thing, right? Factoring would not be nice. Factoring would not be nice. Okay. But what's the difference now? What do you notice? What's the key difference? Take a look at that. What's the key difference right now with what I'm going to have to do? Okay, I'm not talking about the specific math, but now I'm doing plus or minus the square root of what type of number? Does the work change? No. Done. You know how that is an imaginary. Oh, and you could turn it into root 11 over 2 if you wanted to. Yes, Harry.